is George. Welcome to Edu-spectra YouTube channel. In this channel, we will be dealing with class 9, 10, 11 and 12 mathematics. So today in this video, we will be starting with class 9 maths with chapter number 1, number system. So let us start with our chapter. Okay, so chapter 1, number system. As the name suggests, in this chapter we will be dealing with numbers, its classification and various other things. So let us start. So first of all, we all know from our lower classes about number line. Okay, in a number line we know we have 0 at the middle and towards the right side we are having the positive numbers till positive infinity. Okay, this is the symbol which we use for infinity. Okay, you can make a note of it, infinity. Okay, it is just like an inverted 8. Okay, and towards the left side of the number line we are having the negative numbers up there, the negative side of infinity. Okay, and between any two numbers, for say between 0 and 1, we know there are various decimal numbers. For example, if I take 1 by 2, which is 0.5, it lies between 0 and 1. Similarly, 1 by 4, which is 0.25, it also lies between 0 and 1. And we know between any two numbers like 0 and 1, 1 and 2, 2 and 3, etc., there are various decimal numbers. Okay. So this is something which I have been learning from our lower classes. Okay, now the next thing which we come across here is about natural numbers, whole numbers and integers. So natural numbers can be represented by capital letter N because it starts with N over here. Similarly, whole numbers is represented by capital letter W because it starts with W. And similarly, integers is represented by capital letter Z. It is not represented by capital letter Z. Okay. So now, let us see what are natural numbers. Natural numbers are the non-decimal positive numbers up till infinity without including 0. For example, if I say 1, 2, 3, 4, etc. up till positive infinity. Okay, these set of numbers are called as natural numbers. Okay, that is 1, 2, 3. These are the positive numbers and it should not be a decimal. These should be non-decimal numbers. Okay, up till positive infinity. Okay, now if I say about whole numbers are those set of non-decimal positive numbers including 0. So I am including 0 over here, 0, 1, 2, 3, etc. up till positive infinity. So here the difference between the natural number and a whole number is that natural number does not contain a 0 but whole numbers includes a 0 also. So that is the difference between natural number and whole number. And also you should be knowing in both the natural numbers and whole numbers we are including non-decimal numbers. We cannot include fractions, decimals, etc. in these set of numbers. Okay. Now the next set of classification is integers. Now integers can include the negative numbers 0 and the positive numbers. For example, if I say from -2, -1, 0, 1, 2, 3, etc. till positive infinity. Here also up till negative infinity. Okay, so you should be knowing that integers are those numbers which consist of the negative numbers, 0 and also the positive numbers. And one thing that you should be remembering here is that here also we are not including decimal numbers or the fractions. Okay, integers are also non-decimal numbers containing negative numbers, 0 and positive numbers up till the infinite. Okay, I hope I am clear with it. Now the next set of numbers or the next classification which you have also learned in your lower classes is rational numbers. Okay, rational numbers. So we know rational numbers, you know the definition. Rational numbers are those numbers which can be written in the form of p by q, where p and q are integers and q not equal to 0. So we know can be written in the form of p by q, where q not equal to 0. Basically rational numbers are those fractional numbers. For example, if I say 1 by 2, if I say 2 by 3, if I say 0 by 1, if I say minus 1 by 2, etc. All these are rational numbers. Why? Because all these can be written in the form of p by q, where q not equal to 0. Now, why am I saying it q not equal to 0? Let us understand that. For example, if I write 2 by 0 and 0 by 2. What are the answers for it? If I ask you what is if I ask you what is 0 by 2, what can you say? 0 by 2 means, like, just imagine that your friend has 2 chocolates and you are asking him to give no chocolate, which definitely will not happen. So if you are asking him to give no chocolates, then what will be your answer be? 0 itself, isn't it? But now if I ask the reverse, that is 2 by 0, that is your friend has no chocolate, but you are asking him to give 2 chocolates. If he has no chocolate at all, from where will you give the 2 chocolates? So here, if he does not have 2 chocolates at all, then he cannot give him 2 chocolates. So such a situation is not defined. Okay, this is a concept which you should know. 0 by 2, if you are saying, if the denominator comes as 0, then it means that from 2 chocolates you are giving no chocolate, so it is 0. And here, if he has no chocolate at all, from where can you give him 2 chocolates? So such a situation is always not defined. I hope I am clear. That is why in the definition they are saying q not equal to 0. So if q become equal to 0, what will happen? Such a situation will be not defined. Okay, in mathematics. So we always say q not equal to 0. So I hope you understood about rational numbers also. Okay, now one small thing here which you should be knowing, which is mentioned in your Ncert text, is about equivalent rational numbers. Okay, let us take your example of your text itself and understand. For example, if I am taking these numbers, let's say 1 by 2, 2 by 4, 10 by 20 and 25 by 50. You have to show that all these numbers which I have written on the board are equivalent rational numbers. That means we have to prove all these values are equal. So here we are having 1 by 2. Now just look at the next number, 2 by 4. We know 2 divided by 4, we can cancel 2 by 4 as. Just see over here. We know 2 times 1 is 1 and similarly 2 times 2 is 4. So here also we will get 1 by 2. So from here we got 1 by 2 is equal to 1 by 2. That is, I simply cancelled off this 2 and 4. So I am getting it the same as that of 1 by 2. Similarly here also 10 by 20. If I cancel these two zeros, here also I will get it as 1 by 2. Similarly here also we know 25 times 2. So here also when we cancel it, 25 into 2 is 50. So here also we will get 1 by 2. So we got all these equal to each other. Such type of rational number which when we see, we can cancel it off and bring it to the same thing which was given in the beginning. Okay, and if everything becomes equal or every rational number becomes equal, we call them as equivalent rational numbers. Okay. Now let us move on to our example number 1. I hope I am clear till now. Okay, let us move on to example number 1. Okay, so the first question is, are the following statements true or false? Give reason for your answer. Question number 1 is, every whole number is a natural number. Okay. They are telling that every whole number is a natural number. Okay. Definitely it is a false statement. Why? Because we know whole numbers are 0, 1, 2, 3. Okay, I am doing question number 1. 0, 1, 2, 3, 4, etc. up till positive infinity. And natural numbers includes 0, 1, 2, 3, 4 up till positive infinity. So, is every whole number a natural number? No. Why? Because we know that whole number consists of 0, but natural number does not contain 0. So how can every whole number be a natural number? Because natural number does not have a 0. So definitely every whole number cannot be a natural number. But if I ask you the reverse, is every natural number a whole number? Definitely yes, because 1, 2, 3, 4, etc., etc., etc. is also present over here. Okay, so every natural number is a whole number, but every whole number is not a natural number because natural numbers does not consist of 0. So for your example, if they ask you, you can say that the whole numbers consist of 0 and the natural number do not contain 0. So definitely it is a false statement. That is, every whole number is not a natural number. So you can write the first one has false. Okay, now the next question is, every integer is a rational number. Okay, let us see. We know what are integers. Integers includes the negative numbers, 0 and the natural numbers. For example, so they are saying that every integer is a rational number, and we know that rational numbers are those numbers which can be written in the form of p by q. So let us take an example and see. So if I take minus 1, if I take 0, if I take for example 2, okay, all these are integers. Now just I am dividing it by any random number, for example say 2, here I am also dividing it by say 4, here I am dividing it say 10. Okay, so here what do you observe? I wrote 3 integers over here, and all these integers can be written in the form of p by q, which implies that every integer is a rational number, because you can write every integer given to you in the form of p by q. So the second statement given to you is also what? A true statement. Okay, the second statement also given to you is a true statement. Now let us move on to the third part. Okay, what does the third part say? Every rational number is an integer. Okay, let us see. Now they have asked you the reverse of the question number 2. That is, every rational number is an integer. So, is every rational number an integer itself? Definitely not. Every rational number cannot be an integer. Why? Because a rational number can be a natural number, a whole number, and also an integer. It cannot not only be an integeric number. For example, just now I have given you the example. So if I take minus 2 by 3, 0 by 1, or 2 by 3, we know 0 is what? 0 is a whole number, and even though it is a whole number, we can write it in the form of p by q. 2 by 3, 2 is a natural number. Even though it is a natural number, it can be written in the form of p by q. Minus 2 by 3, it is an example of an integer. It can also be written in the form of p by q. That means, okay, you can make a note of it. That is, all natural numbers, whole numbers, and integers can be rational number. Okay, all the natural numbers, whole numbers, and integers can be a rational number. So here also the statement number 3 every rational number is an integer, it is also a false statement, because every rational number need not be an integer itself. It can also be a natural number and a whole number. So here also the third statement is a false statement. Okay, here also the third statement is a false statement. Okay, I hope I am clear with it. Now, let us move on to example number 2. How to do from your lower classes. There may be different methods to do the same as per your example number 2. So let's see. I will give you both the methods, so you can do it in the method which is convenient to you. Okay. So here the question is, find 5 rational numbers between 1 and 2. So I am writing 1 and 2. You need to find 5 rational numbers between them. Okay, 5 rational numbers you need to find between them. So it can be done in different ways. I will show you the two ways also. So the first way which I will be doing it is, okay, let's see. So here, this step number 1 that you should do here is, whatever is the total number of rational number they are asking you to find. Here they are asking you for finding 5 rational numbers. So you have to add a plus 1 to those to that. So I am writing 5 plus 1. If they had asked you 6 rational numbers, then you should have done 6 plus 1. If they had asked you 7 rational numbers, then you should have done 7 plus 1. So that is your step number 1. So 5 plus 1 we know it is equal to 6. Okay. Now, step number 2 is to multiply and divide this 6 with this 1 and 2. I will write over here, multiply and divide this 6 with this 1 and 2. So let's see, we know 1 can be written as 1 by 1, and we have to multiply this 6 with multiply and divide it with 6. So 1 into 6 by 6. So when I do, I will get it as 6 by 6. Similarly, 2 I can write it as 2 by 1. I am multiplying and dividing it with 6. So 2 6 are 12, and denominator also I will get a 6. Okay. Now please don't cancel this 6 by 6 and make it as 1, and this as make it as 2. So we will be definitely getting back a question answer. So just leave it as it is. Now between 6 by 6 and 12 by 6, isn't it easy for us to write 5 rational numbers? So how will you write the 5 rational numbers in between these two numbers? I can write 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. See, exactly I got 5 rational number between these two numbers. Okay. Now, when you write these 5 rational numbers, never include 6 by 6 and 12 by 6 as your rational number. They are asking you to find in between. So you should always start from 7 by 6 and end at 11 by 6. You cannot include these two. Okay. So from here we got 5 rational numbers between any two numbers. This is the first method in which we will do. Here when we see, here the speciality of this method is that exactly we will get the 5 rational numbers, nothing greater or nothing less. Okay, so 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6 are your 5 rational numbers between 1 and 2. Okay, so I will also do the other method also. Whichever method is convenient to you, you can use. Okay, so the other method is that we are having this 1 and we are having this 2. 1 I know I can write it as 1 by 1, 2 also I can write it as 2 by 1. Okay, now that's next thing I am going to do here is that multiplying and dividing this 1 with 10. Why am I doing so? Because so when I do this, I will get over here as 10 by 10. If I cancel these 0, I will get back by 1 itself. So there is no problem. When you are manipulating in the numerator, the same manipulation you have to do in the denominator. Similarly, here also I am multiplying and dividing it with 10. So what will I get over here? 2 tens are 20 and here I will get 10. Now here also it is very easy for us to find 5 rational numbers between 10 by 10 and 20 by 10. So what are those numbers? 11 by 10, 12 by 10, 13 by 10, 14 by 10 and 15 by 10. Okay. So here also we have gotten a 5 rational numbers between 1 and 2. Okay, that is 11 by 10, 12 by 10, 13 by 10, 14 by 10, 15 by 10. Here there are also many more rational numbers between them. So, but we only need to write 5 of them. So, this is the other method. That is simply multiply and divide this 1 and this 2 by 10. So, you will get your rational numbers over here. I hope I am clear. Whichever method is convenient to you, you may apply. Now, one more question I will ask to you. So, now here the question was to write find 5 rational numbers. Now, if I ask you how many rational numbers are actually there between 1 and 2, what will your answer be? The answer will be there are infinite number of rational numbers between 1 and 2. There are infinite number of rational numbers. Okay, so definitely we cannot go on finding all those infinite number of rational numbers and keep. That's why they are asking you to find 5 or 6 rational numbers. Okay, so you can, if you want, you can note it down. It can be asked in MCQs and all. There are infinite rational numbers between any two numbers. There are infinite rational numbers between any two numbers. So we cannot go on finding all those rational numbers. So they will specify to us to find only a particular one. Let us move on to our exercise number 1.1. Okay, exercise number 1.1. Let's see. Okay, so here we are having 4 questions. Let's do it fast. So, the question number 1 is 0 a rational number? Can you write it in the form of p by q, where p and q are integers and q not equal to 0? Okay, I am doing the first question over here. So, is 0 a rational number? Yes, definitely. 0 is a rational number. So, as per the definition of rational number, we know rational numbers are those numbers which can be written in the form of p by q and q not equal to 0. Let's take here 0. 0, how can I write? 0 I can write it as 0 by 1. Similarly, I can write 0 as 0 by 2. I can also write it as 0 by 3. In the beginning also I told you what is 0 by 1? My person has 1 chocolate but he is not giving me any chocolate. So the answer will be 0 itself. Here also 0 by 2 is equal to 0. 0 by 3 is also 0. So definitely 0 can be written in the form of a fraction. That is, it can be written in the form of p by q, where q not equal to 0. So yes, is 0 a rational number? So the answer to the first question is yes, 0 is a rational number. Why? Because 0 can be written in the form of p by q. Definitely it can be written in the form of p by q. Okay. So I hope the first question is clear. Now let us move on to our second question. Our second question is find 6 rational numbers between 3 and 4. Let's see. Our next question is to find 6 rational numbers between 3 and 4. So I will be doing it in both the methods. Okay, so they are asking me to find 6 rational numbers between 3 and 4. 6. Okay, so I am doing it in the step number 1. Step B. Okay, so the first step, what should we do? Here they are asking you to find 6 rational numbers. So you have to do 6 plus 1. That is your first step. Okay, always add plus 1 to the number of rational numbers you are asked to find. So 6 plus 1, you know, it is equal to 7. Okay, now what should we do? We have to multiply and divide this 3 and 4 with this 7. So what will I get? 3, I can write it as 3 by 1 into 7 by 7. Multiply and divide it with 7. So I will get 3 sevens are, we know it is 21 and by 7. Here also 4 I will write it as 4 by 1 into 7 by 7. So here also 4 sevens are, we know it is 28. And here I will be getting it as 7. So here also what will be my rational numbers? 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. Okay, so here also we got exactly what? Exactly 6 rational numbers between 3 and 4. Once again I will repeat. In the question they have asked you to find 6 rational numbers. You have to add 1 to the total number of rational numbers they are asking you to find. So 6 plus 1 I got it as 7. The next step is you have to multiply and divide this 7 with this 3 and 4. That is the numbers in between you have to find. So I will get 3 by 1 into 7 by 7, which is 21 by 7. 4 by 1 into 7 by 7, which is 28 by 7, and it is very easy for us to write 6 rational numbers between 21 by 7 and 28 by 7. Okay, these are the rational numbers: 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. Okay. So here also we will be getting exactly 6 rational numbers between 3 and 4. That is 31 by 10, 32 by 10, 33 by 10, 34 by 10, 35 by 10 and 36 by 10. I hope I am clear. Okay. Either way you can use and you will be getting 6 rational numbers. Okay. So this is your answer. Okay. Now let us move on to our third question now. Okay, let us move on to our third question. Our third question is find 5 rational numbers between 3 by 5 and 4 by 5. Okay, that is our next question. We have to find 5 rational numbers between 3 by 5 and 4 by 5. Okay, so here also first I will do with the method number 1. So here they are asking you to find 5 rational numbers. So you have to do what? Add 1 with this 5. So 5 plus 1 we know, we will get it as 6. So we got your 6. Now what should we do? We have to multiply and divide this 3 by 5 with this 6. So I will get 3 by 5 into 6 by 6. So I will be getting it as 18 by 30. 5 6 are 30. Here also 4 by 5 I will be doing. So I will get 4 by 5 into 6 by 6. So 4 6 are 24. Okay. So now let us see the other method. So I will run this. Now for the other method, what we have to do is multiply and divide it with 10. So I am having 3 by 5 into 10 by 10, which is equal to 30 by 50. Here also 4 by 5 into 10 by 10, which we will get it as 40 by 50. So you can write 5 rational numbers definitely between these two fellows. So I will get 31 by 50, 32 by 50, 33 by 50, 34 by 50 and 35 by 50. So these are my 5 rational numbers between 3 by 5 and 4 by 5. Okay, between 3 by 5 and 4 by 5. Okay, so any method you can adopt to find it. Okay, the first method which I did or this method which I did. Okay, now let us move on to our last question in our exercise, which is the fourth question. That is, state whether the following statements are true or false. Give reason for your answer. So let's see. Question number 4 is every natural number is a whole number. Okay, this is just like the question that we had done in our example question. So we are having natural numbers, whole numbers. Natural numbers we know, non-decimal, positive numbers, etc. till positive infinity. whole numbers include 0, 1, 2, 3, etc. till positive infinity. So here the question is, every natural number is a whole number. Yes, definitely. We see every natural number, that is 1, 2, 3, 4, etc. are whole numbers, because all natural numbers which are present are also present in the whole number region. But if I had asked you the reverse, is every whole number a natural number? Definitely no. Why? Because 0 does not belongs to natural numbers. So here the question is, every natural number is a whole number. Yes, 1, 2, 3, etc. is also belonging to the whole numbers. So definitely this is a true statement. So the first part of to the question is true. Okay, now let us see the second part. The second part is, every integer is a whole number. So definitely that is a false statement. Why? How can every integer be a whole number? We know what are integers. Integers include the negative numbers, 0, and also the positive numbers which goes up till infinite. Okay, and we know whole numbers are the positive numbers also including 0. So is every integer a whole number? Definitely no. Why? Because whole number does not have negative numbers, but integers have. So we cannot say that every integer is a whole number, because integer also has negative numbers, but whole numbers do not have negative numbers. So every integer is a whole number. It is a false statement. Okay. So it is a false statement. Okay. Now the next question, the third question is this is a similar question that we had done in the example also. Every rational number is a whole number. In our example, number is a whole number. So that is also what? That is also a false statement. Okay. Why? Because as I said, it can be a whole number, it can be a natural number, it can also be an integer. So as I had given you the example, if I say 1 by 2, 0 by 2, minus 1 by 2, whatever. This is a natural number, this is a whole number, this is an integer. So natural numbers, whole numbers, integers, everything can be a rational number. So saying that every rational number is a whole number, it is definitely a false statement. Okay. So that's it. Okay, so here in this video we have completed exercise 1.1 and example number 1 and 2. So thank you. We will meet in our next video starting off with irrational numbers.